Mars has a solid inner core, resolving a long-standing planetary mystery. New study. Scientists have discovered that Mars has an interior structure similar to Earth's. Results from NASA's InSight mission, science.nasa.gov/mission.insight, suggest that the red planet has a solid inner core surrounded by a liquid outer core, potentially resolving a long-standing mystery. The findings, which are published in Nature, https://www.nature.com/articles/S41586-025-0931, have important implications for our understanding of how Mars evolved. Billions of years ago, the planet may have had a thicker atmosphere that allowed liquid water to flow on the surface. This thicker atmosphere may have been kept in place by a protective magnetic field, like the one Earth has. However, Mars lacks such a field today. A key property of the Earth is that its core has a solid center and liquid outer core. Convection within the liquid layer creates a dynamo, producing the magnetic field. The field deflects charged particles ejected by the sun, preventing them from stripping the Earth's atmosphere away over time, and leading to the habitable conditions we know and enjoy. From residual magnetization in the crust, we think that Mars did once have a magnetic field, possibly from a core structure similar. However, the Martian atmosphere is thin today, and the necessary amount of water is nowhere to be found. Teams working with the seismometers on NASA's InSight Mars lander first identified https://www.science.org/doi/science ABI7730, the Martian core, and determined that it was actually still liquid. The new results from Qingxing Bi at the University of Science and Technology of China in Hefei and colleagues show that there may also be a solid layer inside the liquid core. The nature of the interior structure of Mars has been an intriguing mystery. Was it ever like Earth's, with a dynamic liquid layer around the solid center? Or did Mars's smaller size prevent such a formation? How big must a planet be to gain the protection of a magnetic field, like Earth's, and support a habitable climate? To understand what happened, how Mars evolved, we need to understand Mars today. These questions about Mars's atmosphere, water, and core have motivated several high-profile Mars missions. While the NASA Mars rovers Spirit, https://science.nasa.gov/mission/mer Spirit, Opportunity, https://science.nasa.gov/mission/mer Opportunity, Curiosity, https://science.nasa.gov/mission/mer Perseverance, have studied the surface mineralogy. The European Space Agency's ExoMars Trace Gas Orbiter is studying the water cycle. NASA's MAVEN spacecraft, https://science.nasa.gov/mission/MAVEN, is studying atmospheric loss to space, and NASA's InSight lander was sent to study seismic activity. In 2021, Simon Stahler from ETH Zurich in Switzerland and colleagues published a seminal paper, https://www.science.abi7730, from the InSight mission. In it, they presented an analysis of the way that seismic waves pass through Mars from Marsquakes in the vicinity of InSight, through the mantle, through the core, and then reflecting off the other side of the planet and reaching InSight. They detected evidence of the core for the first time and were able to constrain its size and density. They modeled a core with a single liquid layer that was both larger and less dense than expected, and without a solid inner core. The size was huge, about half of Mars' radius of 1,800 kilometers, and the low density implied that it was full of lighter elements. The light elements, such as carbon, sulfur, and hydrogen, change the core's melt temperature and affect how it could crystallize over time, making it more likely to remain liquid. The solid inner core, 610-kilometer radius, found by Huxing Bi and colleagues, is hugely significant. The very presence of a solid inner core shows that crystallization and solidification is taking place as the planet cools over time. The core structure is more like Earth's, and therefore more likely to have produced a dynamo at some point. On Earth, it is the thermal heat changes between the solid inner core, the liquid layer, and the mantle that drive convection in the liquid layer and create the dynamo that leads to a magnetic field. This result makes it more likely that a dynamo on Mars was possible in the past, with Simon Staler and co-authors reporting a fully liquid core and Hoxing B and colleagues reporting a solid inner core. It might seem as if there will be some controversy. But that is not the case. This is an excellent example of progress in scientific data collection and analysis.